Welcome to one of the shorter videos. Today we're going to talk about naming acids, and this is actually pretty easy. Alright? Now, before we get to naming, you got to understand what an acid is. It adds H plus ions to solution. That's what we define an acid as. And another way to talk about H plus, because a hydrogen atom is one proton and one electron, H plus has lost that electron. So H plus ions are actually just protons. That's all they are, protons floating around in solution. So first we're going to talk about the diatomic acids, and there's 4 of those. We're going to talk about 2 of them that are very, very common, and then the other 2 we'll see if you can come up with on your own. All right? But the way we name them is very easy. HF, we have hydrofluoric acid. That's it. And so when we talk about HCl, it's not, of course, hydrofluoric acid anymore. We have hydrochloric acid. So there are 2 more diatomic acids, and we'll see if you can come up with those on your own. The other types of acids are polyatomic acids, and this goes back to our polyatomic ions. Essentially what we're doing is we're adding hydrogens until the charge of that polyatomic ion is 0. So as we start adding hydrogens, we move closer and closer to 0. Our naming scheme is, I don't know the history behind it, but it does make sense. The ending "ate" turns to "ic", and then you add the word acid. And the ending "ite" turns to "us", and then the word acid. And it's best shown in some examples that I have up here. First, NO3- is nitrate. As soon as I add a hydrogen to nitrate, the charge goes from -1 to 0. All right? When we do that, it's no longer nitrate. You can see that we have the 8 here. That 8 turns to "ic", and I've added the word acid. All right, so not too bad. Here, carbonate, add 2 hydrogens, it becomes carbonic acid. Now over to the us acids. NO2- is the nitrite ion. When we add a hydrogen, we get nitrous acid. Here, SO3- is sulfite. We add 2 hydrogens, sulfurous acid. And the reason I'm showing you how this is done because the number of organic acids is huge. It's an absolutely enormous library, but it allows us to name the ion that stems from the acid very easily. For instance, you guys probably have never heard of ascorbate. Well, ascorbic acid is better known as vitamin C. So we have ascorbic acid here. When it loses a hydrogen, then it gets a -1 charge. It is an acid. That ic acid ending then changes to 8. Just as if we added hydrogens and went 8 to ic, now we're going ic to 8. I know that sounds a little weird saying, but it's actually a really nice system, and it's pretty easy to use once you get the hang of it.